I'm going to redo the video for today since I did not set up one of the problems correctly, so I want to fix that. We were just wrapping up chapter 7 by doing some problems from the book that are similar to what you're going to see on the test. So 758 was the first one. Okay, so this is going to be using your product property. Log of m plus log of n is log of m times n. As long as the bases are the same, this will work. So then that would be log of 1,000, which could be simplified further if the base is 10. If there's nothing written there, then the base is 10. So this is saying 10 raised to some power, we can put a y there, equals 1,000. Well, that would be 3. 10 to the third power is 1,000. Okay, for part B, we have log base is 25. Okay, so we could just rewrite this as an exponential. This is 5 squared, this is 5 to the third power. I'm thinking let's just rewrite it. So this means 25 raised to this power equals 125. So when the exponent is a variable, we can take the log of both sides, and that would give us y times log of 25 using, I'm using the power property. If that exponent needs to be isolated, you can take the log of each side and bring that exponent down in front of the logarithm. So y log 25 equals log 125. And then to get y by itself, divide both sides by log 25. So that would be 1.5, 3 over 2. Okay. Part C, we had 1/2 log 25 plus log 20. Okay. I'm going to use the power property in reverse here, because 25 to the 1/2 power, that's just the square root of 25, which is 5. So I'm going to put this in the exponent. So log 25 to the 1/2, that's the 25 to the 1/2 is the square root of 25, which is 5. So this is log of 5 plus log of 20, and then I'm going to use the product property, and that would be log of 100. Whoops. And that, if the base is not written, that means you can assume it's 10. 10 raised to what power is 100? 10 to the second power is 100. So that final answer would be 2. This is a rule, we just haven't done it yet. Okay, the bases are the same here, so I'm going to look at just this right here. Base is 7 of 12. I'm going to say, what does that mean? That means that 7 raised to the y power equals 12. So this means this base raised to this power equals 12. I don't know what that is, but if I let this be equal to y, I could rewrite this as 7 to the y power. So I'm just substituting y for log base 7 of 12. And I just wrote over here what that is. So 7 to the y is 12. This means 7 raised to something equals 12. Well, if you're raising whatever that is to get, you're raising 7 to that power, then you're going to get 12. That's actually a rule. If the bases are the same, it's just going to wind up being whatever that is. That's not on the test, but I think it's a good one to see. I don't think it's on the test. No, it's not a test. Okay. We also did, and this is where I got stuck, 771. And it's because I didn't include the asymptote from the beginning. So I'm going to show you how to do it with the asymptote. This is in lesson 722. And it's problem 771. Okay, it says write the equation of an exponential function of the form y equals a b to the x plus k. And I should have included that asymptote from the very beginning and not tried to adjust it at the end. Okay, so I've got the point -1, -0.2. And I've got the point 4, 24, 99. And you're probably noticing, I mean, 0.2, this is almost 2,500. And it's got, in 5 intervals, it's going from 0.2 to 2,500. So it's probably related to raising something, multiplying something by 5. But I want to make sure you know how to do this algebraically. This is on the test with the asymptote in it. Okay, so we can plug these points into the equation. But we have to include this asymptote, and that's the part that I was leaving off. You could put plus -1 or -1. That is where it's going to level off. So I'm going to plug in -0.2 for y, -1 for x. I'm going to solve for a. And I'm going to do the same thing with this point. So I'm going to plug in 24.99 for y, 4 for x, and I'm going to solve for a over here, and then I'm going to set them equal to each other. It's a system of equations. So whatever way you want to do that, you could get a by itself here and substitute in over here. I don't know, I just think it's a little bit nicer if you get a by itself on both of them. So I'm going to add 1 to each side. So let's see, that would be 0.8 equals ab to the -1. And then I'm going to divide both sides by b to the -1, which is going to give me a equals 0.8 over b to the -1. Here, I'm going to add 1 to both sides. Same thing. Divide by b to the 4th. And then I'm just going to set these equal to each other. And then I'm just going to solve for b. So could cross multiply. Then you could divide both sides by 0.8. That's 2,500 divided by 0.8, 3125. B to the Then I'm going to divide both sides by b to the negative 1. So when you're dividing powers, you subtract. So 4 minus negative 1 is 5. So then this is b to the 5th equals 3125. And then I'm going to just take the 5th root of each side. And that is 5. So then our equation is y equals a times 5 to the x minus 1. And I'm just going to plug in another one of these points that was given and solve for a. So let's say I plug in this one, 2499 equals a times 5 to the 4th minus 1. I'm plugging in 4 for x, 2499 for y. That's going to give me I'm going to divide both sides by 5 to the 4th would be 625. And that is 4. So then our equation would be y equals 4 times 5 to the x minus 1. And I got stuck. I totally was thinking we were going to fool with that asymptote and adjust it later. But you need to plug it in from the beginning. You could get it from just playing around with Desmos, but it's much easier, I think, to just do it algebraically. I'll do another one like that. So if I went too fast on that, or if you just need another one to practice with, because we probably haven't done a whole lot of this with the asymptote there. So you could try this next one and then just check and see if you've got it right. Okay, so I'm going to write an exponential equation that goes through these 2 points, and you could check this on Desmos. So the very first one, let's see, what did we get for the last one? The last one we got y equals 4 times 5 raised to the x minus 1. And there it goes through our 2 points. I had put the 2 points into Desmos. It goes through those 2 points, and it does have an asymptote. It's kind of hard to see, but there's an asymptote at -1 just because the scale goes all the way up to 2500. Okay, so I'm gonna do this next one. If you want to pause the video and try it on your own and then see if you get it right. I'm just gonna plug in y and x. And then I'm gonna put +7 because it's got an asymptote at 7. So same thing, just subtract 7 from both sides. Solve for a. Let's just do this one. I'm going to do this one by substituting. I'm just going to take this, substitute it in the place of a. So that would be just to change it, give you another option. Winds up being the same thing. Okay, so let's see, we've got b to the fourth over b squared. That's going to be 4 minus 2, so that's going to be 0.96 b squared plus 7. And then I'm going to subtract 7 from both sides. That's a b. So 0.1536. Okay, point divided by 0.96 equals b squared. So I'm going to take the square root of each side. And the square root of 0.16 is 0.4. Maybe that's a little bit shorter, I don't know. So b is 0.4. Then I just need to solve for a. So y equals a times 0.4 raised to the x plus 7. That's your asymptote. So plug in either of these points. Okay, solve for a, so subtract 7 from each side. Divide both sides by 0.16. So then our equation should be y equals 6 times 0.4 raised to the x plus 7. And you could check that on Desmos, which I think I've got them in here already. Get rid of all this. Okay, y equals 6 times 0.4 plus 7. There it is. Got your asymptote going through 7. You could put it. There it is right there. There's your asymptote. There we go. Okay. We didn't do much because I spent a lot of time being stuck on that. But I did do a couple of other problems to review the properties of logarithms. 773 was one. It says given that log base x of 2 is a, log base x of 5 is b, log base x of 7 is, write the expressions using a, b, and c. So we could take log base x of 10. Okay, I think I wrote those on a card so I could have them handy. We could take log base x of 10 and change that to log base x of 2 plus log base x of 5, because the product property, that's just the product property going in reverse. So you're taking the 10, changing it to the 2 and the 5. Okay, and then if you wrote it with a, b, and c, it would just be a plus b. And then log base x of 49. Okay, you could write 49. If you're trying to write it in terms of just log base x of 7, you could write this as log base x of 7 squared, and then you could use your power property and bring that in reverse and bring that 2 down in front. So 2 log base x of 7, and then you could write it as 2c if this is c. I think, let's see, log base x of 50. So log base x of 50, we could rewrite that as log, so you're trying to write it in terms of 2, 5, or 7. So that could be log base x of 5 plus log base x of 10, which, whoops, I'm not even showing you. Okay, for this one, you could rewrite this as log base x of 5 plus log base x of 10. You've already got this one rewritten as log base x of 2 plus log base x of 5. So then you've got basically 2 log base x of 5 plus log base x of 2. And if you write it with C and A, B, and C, that would just be 2b, this is b, and then plus a. So it's just reviewing those properties. And I did say this in class, and it's important. If you haven't done the con assignments, evaluate logarithms advanced, relationship between exponentials and logarithms, solve exponential equations using logarithms and other bases, use properties of logarithms. Those are kind of old, but those are going to be really helpful for the test. I know you have a ton related to exponential equations, but don't skip these. Okay, I think these are going to be very helpful. Okay, I think I stopped there and started doing a different one, because 56 you could just rewrite as 7 times 8. Oh, but then you would have, okay, you'd have to rewrite 8 as 2 to the 3rd. I didn't do that one in class. I can do it real quick. Let's see, log base x of 56. So you could rewrite that as log base x of, let me write it right here, log base x of 7 plus log base x of 8, and then log base x of 7 plus log base x of 2 to the 3rd. And then you can use power property and just bring this down. If your goal is to have everything in terms of these 3, that's why I'm changing it to that. So then that would be 3 log base x of 2. This is C, and then this is A, so this would be C plus 3A. All right, and then I think we did maybe 1 or 2 more. Let's see, that was 773, 723, and let's go to 723. And 784. Okay. Barnaby's grandfather is always complaining. This is another one where you're writing an exponential equation. So if you need more practice with this, it would be a good one to do. He is always complaining that 50 years ago he could buy his girlfriend dinner for $1.50. Now that same dinner costs $25.25. Assuming the prices increased exponentially and that same dinner never costs less than 0.2, less than 20 cents, write the equation of a function that models the cost in relationship to the number of years from now. So it's the same thing that we were doing just a little while ago. Okay, what do we have? We have the point. Now we could think of 50 years ago as being the starting point, or we could think of the dinner now as being the starting point, and it really doesn't really matter which way you think of it. I'm going to do 50 years ago. 0 is $1.50, and then so then 50 years later it's worth $25.25, and my asymptote is going to be y equals 0.2. So I'm using 50 years ago, it cost $1.50, so then 50 years from then it's $25.25, asymptote is 0.2. So that's going to be $1.50. Oh, this one's going to be easy because anything to the 0 power is 1, so A is $1.50. That's the starting point. And then just plug in you could plug in this other point. To solve for B. So let's see, what's that? Divided by 1.5 is 16.83 equals B to the 50th. So I'm going to raise this to the 1 over 50th power. That's taking the 50th root. Oops. I don't think I did that right. Hold on a second. Whoops, I put 1 raised to the 50th instead of 1 over 50. Let me try that again. 25.25 divided by 1.5 is this. Raised to the 1 over 50. Oops. Is 1.06. So B is 1.06. Okay. Oh, I forgot the whole asymptote thing again. Darn it. Back up. So used to doing it that way. Okay, so then that's going to be 1.50 equals A, B to the 0 plus 0.2. I forgot the asymptote again. Oops, get this out the way. Okay, so that's going to give me a different answer. 1.50 minus 0.2 is 1.3 equals A, B to the 0. Okay, so A is 1.3. A is 1.3. Plug that in. And don't forget the asymptote, like I keep forgetting. Okay, so plug in this point, 25.25 equals 1.3 times B to the 50th plus 0.2. Okay, so 25.25 minus 0.2 is 25.05. I'm going to divide both sides by 1.3. Uh, 19. Okay, and then I'm going to raise that to the 1 over 50th power. Okay, we still get about the same thing, 1.06. So I think this is going to be y equals 1.3 for A times 1.06 to the x plus, let me move this over, plus 0.2, but I'm going to check and make sure. I'm not sure that's right. Okay. for our 2 points? 0 and 1.5. And then 50 years later, it's worth 25.25, right? Okay, so we got, let's see, here's 0, 1.5, and let's change this window. Let's get rid of this. Change this to and let's change this to we'll start with 100. It might adjust it. Okay, what did we get? Y equals 1.3 times 1.06 raised to the x plus 0.2. That seems a little bit off. I might have rounded off a little bit when I did that 1.06. Let's put 1.0609. 55. That's a little bit better. So that was when I cut that off a little bit, but it turns out we need those decimal points. And I think it had a follow-up question. How much would you expect for the same dinner to cost 60 years from now? Okay, so now was the 25.25. So that was, I had written that as 50. I had said 50 years later, it's 25.25. So 60 years from now would be 110. And I'm trying to figure that out, so I'm just going to use my equation. And 110, let's adjust it so we can see it. And we do 130. And let's change, let's just do this. And then do f of 110. $872. I hope not. 60 years from now. That's what this equation says. Okay, hope this helps. Good luck with everything this week. See you later.